In the article, published in the Journal of Strength and Conditioning Research, Beato and colleagues discuss the rational application of eccentric-based exercises in sports, where they focus on 4 main methods, including tempo-eccentric training, accentuated eccentric loading, plyometric training, and flywheel resistance training. This is Talking Sports Science with a summary of their article. When it comes to performing eccentric tempo exercises, it typically involves increasing the duration of the eccentric phase before performing the concentric phase, which increases the overall time under tension. Although traditionally loaded with submaximal loads to allow for the concentric phase of the lift to be performed, eccentric tempo training can also be performed using maximal or supramaximal loads by performing eccentric-only movements, i.e. negative training, where the aim is to control the eccentric phase of the movement to the end range of motion, or not completing the concentric portion of each rep. While research examining tempo training performed with negatives is limited, this method may allow for higher threshold motor units to be recruited, therefore enabling favourable adaptations to occur within fibres that have the capacity for greater magnitudes and rates of force development. However, the regular use of supramaximal eccentric training may increase the risk of injury, so it's only really recommended for athletes with extensive strength training experience. In contrast to eccentric tempo training, accentuated eccentric loading involves the use of greater loads during the eccentric phase compared to the concentric phase, while preserving the stretch shortening cycle, and the overload imparts minimal disruption to the exercise technique. Typically, accentuated eccentric loading is implemented with traditional resistance training exercises, such as the back squat and bench press, using weight releasers, whereby additional load is added to each sleeve of the barbell and is removed near the end range of motion on the downward phase of the exercise. Accentuated eccentric loading can also be used with loaded jumps, where the load, i.e. dumbbells or kettlebells, are dropped at the bottom of a counter movement. Acutely, accentuated eccentric loading, using weight releasers, can improve concentric peak power, rate of force development, 1 repetition maximum, eccentric velocity, concentric velocity, and enable a great amount of work. Also, using accentuated eccentric loading only on the first rep in a set may provide a potentiation effect on later repetitions. This prevents the need to re-wrap the barbell in between reps and reload the weight releasers, therefore improving training efficiency while still providing the benefits. From a submaximal standpoint, 20 kg accentuated eccentric loaded jumps has been found to acutely improve jump height as well as peak force, velocity and power output. Therefore, acute accentuated eccentric loading may serve as a potent acute stimulus that may alter eccentric and concentric metrics. And stronger athletes may achieve greater benefits when using accentuated eccentric loading compared to weaker athletes. While fewer studies have explored the long-term effects of accentuated eccentric loading, those that have typically have used common strength training exercises over a 5 to 10 week period, which in most cases has led to increase in maximal strength alongside improvements in jumping and sprinting. Also, performing accentuated eccentric loading jumps for 5 weeks has been found to improve jump height, velocity and power output to a greater extent in comparison to just bodyweight jump training in a group of volleyball players. These results may be explained by changes in the neuromuscular system. Moving on to plyometrics. In essence, plyometric training offers a unique eccentric stimulus, despite not being classified strictly as eccentric training. Movements like drop jumps and repeated jumps are in their own right a method of eccentric training. This is because when an athlete descends towards the ground, both acceleration and gravity contribute to increased landing force, emphasizing the eccentric phase. By increasing drop jump or rebound height, it is assumed that this will result in greater force being exerted into the ground upon landing, as there is more distance for them to accelerate to the floor. On landing from a drop jump or subsequent rebound, when using accentuated eccentric loading, an athlete would have to increase force as opposed to that of a bodyweight drop jump. Therefore, knowing the acute effects of plyometric jump training is important. For example, heavy loads facilitate maximal force production, while unloaded conditions target peak velocity and power. To avoid performance detriment, especially for athletes with high body masses, it is important to consider drop jump heights and accentuated eccentric loading loads. For counter movement and drop jumps, loads around 10 to 30% of body mass are effective to improve various jumping metrics. And moving on to flywheel resistance training, which involves the use of rotating flywheel discs or cones to provide resistance. The concentric action is initiated by pulling the strap connected to the shaft of the device, spinning the flywheel. Once the strap rewinds around the shaft, an eccentric action is performed to decelerate the flywheel rotation. From a mechanical perspective, the impulse produced during the descending phase is influenced by the moment of inertia selected, mechanical characteristics of the devices used, and the timing, range of motion, and force exerted by the user during the concentric phase. The advantages of using flywheel technology lies in the ability to produce high mechanical loads during both the concentric and eccentric phases of exercises like squats. It's worth noting that the mechanical outputs during the eccentric phase can match or even surpass those generated during the concentric phase. This is typically referred to as eccentric overload. This is why flywheel resistance training is acknowledged as an effective method for eccentric resistance training. Yet the benefits aren't solely attributed to the eccentric phase. For instance, the mechanical outputs, for example power, during the concentric phase can be extremely demanding, sometimes even more so than during the eccentric phase. Moreover, the load generated during the concentric phase is essential for producing the eccentric load. Therefore, it's important to highlight that both acute and chronic adaptations from flywheel resistance training aren't exclusively tied to the eccentric phase, as the concentric phase also significantly contributes to the outcomes. The acute adaptations from flywheel resistance training are typically associated with the physiological phenomenon known as post-activation performance enhancement, whereby performing multiple sets, for example 2 to 3 sets of 6 reps, of flywheel squats, deadlifts, and single leg exercises can be used to acutely improve jumping, change of direction, and isokinetic strength across various populations. Regarding the post-activation performance enhancement time window, potentiation can occur following a recovery period, usually lasting between 3 and 9 minutes. Regarding chronic morphological adaptations, flywheel training is a valid alternative to traditional resistance training for improving hypertrophy, strength and power in both untrained and trained populations. For example, trained soccer players can achieve strength and power adaptations with a training frequency of between 1 to 2 sessions per week, and in young and elderly females, 1 to 3 sessions per week can be a safe and time-efficient strategy for enhancing physical outcomes. And that concludes the considerations and suggestions for implementing eccentric resistance training. It should be noted that eccentric stimuli can be obtained during other exercises, such as downhill running, decelerations, and sprinting activities. However, the quantification of the eccentric load during these training modalities is problematic. Lastly, it should be highlighted that a single silver bullet training modality does not exist. Consequently, Marco and colleagues recommend using a combination of eccentric-based training approaches, and that the approaches used be integrated into the athlete's overall training program. And that concludes this presentation. Thanks for listening, folks. See you next time.